first, let me explain about the architecture of the HDFS, which is the Hadoop, the distributed, the file system. So as name implies the distributed file system, as I explained, this is based on the master node. So this is the master node and the slave. So at this time, instead of master and slave, the Hadoop used a different name. So this is called the naming node. So naming node is the master node. We need only one. Okay. Then the others are called data node. So we are going to number data node 1, data node 2, data node 3, and data node N. Here. So we have the number of the slave node, data node, and each of them is the computer. Okay. So mostly nowadays it is suggested around 4,000 to 5,000 at least the price level for each node, which means it's cheap or expensive. It's very cheap from the company, the infrastructure point of view. Each node is less than the 10,000. So then if you have the 100 node is around the million. So million is not that expensive. Okay. So it is suggested 4,000 to 5,000. Especially the naming node is, as you can imagine, the more the powerful the computing resource, like at least the 32 gig. The gigabyte, the memory size, and the CPU should be the higher, so it is recommended. One thing, when you build, for example, if you are asked to design the Hadoop, the system, which one is the most important part to consider? Among the different components of the computer system, like the CPU, memory, the bus, and the graphic card, and the network, which part is the most important?
Memory.
It's the memory. Okay, so you'd better have the the bigger size of the memory, the computing node, even though it's one of the benefits of using the Hadoop, the system, Hadoop solution is cheap or affordable, but you'd gotta have the bigger size of the memory, especially for the naming node, because it's a master. So first the naming node. Naming node has all the metadata. Okay, so what you are going to create the file here. Oh, by the way, actually each of the node has their own operating system, obviously. And then it has the file system, like for example, NTFS, and their own file system. Then when you install the Hadoop, it will install what? HDFS. File system plus number of processes. Okay, the program. So when you start up, think about Oracle Informatics as such a relational database management system. When you start up the database, what happens? File system, their storage will be checked whether they have the correct the file for the data file or the table file, the system file. Then at the memory, they allocate the memory, reserve the memory, then finally starting the process. It's the same thing. So when you start up your Hadoop, after installing the Hadoop file, the Hadoop system, it will start. They will check their. So I'm going to delete the existing one. So all of this will represent the header file system. And then after they check the correct, they definitely doing the checksum and so on. If they are okay, they will start the number of processes. So we are going to see such a number of processes. Okay, so basically this is the Hadoop file system. So there is a client. So client, the would write. Client can be your, we will see later. There are different ways. So like we can use the shell, it's a Hadoop shell. Whether there is a RESTful API, so the RESTful API, and also there are other applications so you can use. So anyway, so for example, map reduce programming. So request the two. First, there is no file, so we try to write a file. So we have the client side. Let's say we are using the shell programming. It's a Hadoop shell. So Hadoop DFS admin or the Hadoop shell. So you are going to learn how to use that. So then we have the client, the server. So we try to upload the file. There is a.txt file. This is like the 1 GB file. So 1 GB file that we try to upload this file to the Hadoop file system. Then first request to the naming node, master node. I try to upload the file. Okay, write the file, the 1 GB file. Then the naming node has all the information about this one. Before we proceed the next step, one of the job of the naming node is checking whether which one is alive or not. So which is called the heartbeat. So every 3 seconds, each node sends I'm alive, I'm alive. So as I mentioned just before, there are different types of failure. The system can be crashed or the data can be corrupted, but most popular failure is a network. So they are definitely connected through the network. So if the network is, if we not received longer than 10 minutes, so they will consider this node is dead. Okay, then they will use a different one. So like that. So the naming node, the monitor, the watch which one is alive, which is slow, which one is fast. So for example, it has the first a.txt file. Need the characteristic of the Hadoop file system. If you remember the database or the operating system class, so both of them we talk about the block size. So what is the block size? When we talk about the block size in the operating system class and database class, it's the I/O unit. Okay, when we read the data, when we write the data, I read the 1 byte of data. So operating system return only the 1 byte of data? No, it return entire block. Okay, that include the 1 byte of data. Database is the same thing. When you read the select name from the student where ID is 111, does it return only the name itself? No, entire block where the name is included will be returned. Then first in the cache. Okay, operating system is the same thing. So even though you update the data, it's not directly update the data, the name. Instead, it will update the entire block. Okay? Then in the memory, then from time to time, write the file. So at the time, it's called the block. So block is the basic I/O unit in the system or application program. Same thing. We have the block size in the Hadoop file distributed file system, which is much bigger. So minimum 64 megabyte and 180 megabyte even, so bigger than 200, so like this one. So nowadays 128 megabyte is popular, but we are going to use the 64 megabyte as a default. Let's say the 64 megabyte, which means even though your MapReduce program reads one line of the data, one record, entire block will be loaded into the memory, which means we need a bigger size of the memory. Most of the processing happen in the memory. That's the reason we need a bigger size of the memory when we build the Hadoop. And then, why is this so big? Any benefit? The operating system block size is a 512 byte. Some of the operating system use the 2K, 1K, something like that. And even database, Oracle used the 4K, 8K, 32K, less than the several megabyte. But this one uses 64 megabyte. This is a big data, right? Which means mostly it's a batch job. It's not online transaction processing. Online transaction processing needs fast response time. Which means if you read all the 64 megabyte, it will be slower because I need only 1 byte. But all 64 megabyte will be cached. So it will take a longer time. However, most of job that are based on the Hadoop is for batch processing, which means we are going to read the entire 1 gigabyte of the data of the a.txt file. Which means once we start to read the data, we will read consequently all the other. So to reduce the overhead, we better use the bigger size. Because this is the basic I/O unit, so we better use the bigger size of the block. So we are going to use the different size of the block, which means the naming node determine the, to simplify, so 150 megabyte. So how many blocks do we need? 3 blocks. Okay, so if we are using the 64 megabyte, so block 0, so block 1 and block 2. So a.txt needs the 3 blocks. Then another information is the block 1. So block 0 is in the first data node 1. Okay, then inform to the client. So data node 1 is the IP address, the 128.0.0.1, and then directly connect. Then write the first block of the a.t, let's say this is the a.txt file, block 0, block 1, block 2. The block 0 will be the a.txt file, block 0 will be the written here. Then another characteristic of this is one characteristic, and another characteristic of the HDFS is it has the copy, multiple copy of the data. As a default, it has the 3 copies. So why do we need the multiple copies of the data? For fault tolerance. In case one of them fails, okay, then we will use another one. So when this one communicate to write the 0, at this time the client does not ask. So block 0 and the naming node assign. So you can use the blocks, the data node 1, data node 2, and data node 3, like this one. At this time, client does not contact the next node. Instead, it will copy the request like this one. Then block 0 will be the stream. It's pipeline right? It's called the pipeline. Okay. Then same thing, contact is the data node 2 contact to reduce the overhead of the client and the name node, and directly the stream and copy. Once they are done, they informed to the naming node. So this is done. And similarly, data are the block 2 are this one is done, and finally this one is done. Okay. Then naming node knows all the 3 copies are successfully copied like this. At this time, it's not randomly selected. Instead, the Hadoop considers the distance and the location of the node. So for example, this is called the rack. The rack is like the cabinet. So most of the, I think if we search the Google, those who never been in the IT, the room, operation room, or the server room, so image like this one. This is a simple rack. So you can see the server room, and then this one. This is called a rack. So then we can put the data node 1 here, and data node 2, and so on. This is one. As you can see, the several racks are together. Data node 1, 1, data node 1, 2, and so on. And the number of rack here. Mostly, they are connected through the network. Directly? No. Through the what? Using switch. Okay? So using the switch, they are connected, which means communication within the rack is much faster than along the rack. Okay? So at this time, we consider the distance inside the same node is there's no distance, and the distance within the rack is called the distance is 2, and along the rack, this is the 4, and this is called the one side data center side, data center side. So we can have the another data center. Okay, so this is sometimes for disaster recovery purpose, or sometimes the distribution purpose. Another data center. This is in New York, and this one is LA, and another data center here. Their distance is called 8, like this one. At this time, when we have the default, the 3, the replica, at that time the 2/3 of the data node, the blocks are in the same rack. 2/3, which means the 2 data nodes. And the 1/3 of them are in the different rack. In case, most of the time, if the switch down, all the node will be down. So because of that, we will use. They do not copy to another data center because it's a long time. It takes a time to make the replica, unless they have more than the 3. Okay. Also, if they are standby node, the side is kind of mirroring. At that time, it's a different concept. Okay. So they consider. They means the naming node consider such a location of the node to decide the replica of that. Okay. What if it has more than 3 copies? There is an equation to calculate the ratio. Well, how many of them are in the same rack? How many of them are in the different rack? Okay, it will be calculated. Most of the time, if you have the Hadoop system, you don't have to worry about too much. But in the real, I try to build the 1,000 node, the Hadoop system, it will be the critical. You need to clearly design such a thing, and in the configuration file, you can specify where the naming node, assign the replica of the node. So this is the one. Then the next, the block number 1 and the block number 2 will be the data node 2, data node 3, and data node n, which means we have the one, and another one, and another one. Also, for example, the data block 2 is the data node 3, data node n, and data node 1, which means the 2, and the 2, and 2, like this. So it has such a replication of the node, and we have the multiple. Any question? It's a very simple idea. It looks like but it was not that simple to manage. As you can see, this is very important. The method. If you lose this one, you cannot identify. Even though in case you lose one or two of the data node, but using this information, you can. For example, I do not have this, but 0, 1, 2 are available. So later, when we recover this system, like the entire system is down, so we replace the new one, it can be easily restored using that information, right? However, if we lose the naming node, we don't know. It's a single point of failure. It is called the single point of failure. It's very important. So first version of the Hadoop, actually only one copy of the naming node. There is the secondary naming node. Secondary naming node is another naming node, but this is not the mirror standby node. Okay? Instead, one of the main job of the naming node is every time it needs to check whether this information is the same as the data, and the images is checked every periodically it checks. Okay, that is really overhead because it access and check the communication and also to keep the log data. So actually, secondary naming node take part of the naming node job. It's a housekeeping job. Then periodically, like every 10 minutes, check it, it's okay, inform to the naming node or update. It's kind of additional, the additional part of the naming node. It's a secondary naming node. It's not standby. Still, it's a single point of failure. So, current version of which means this is not very important. So instead, from the Hadoop version 2, the current version is 3.0, but 3.0 is not much production. It's a release, but still testing a lot. The current version, the Hadoop second version, they have the standby, the naming node. This is the primary, this is a standby. In case this one is not working, then using HA, the technique, HA is the high availability. Hopefully, I'm correct. It's a high availability. Means there is a hardware that can check whether this one is alive or not. In case this one is the die, something network failure or system failure, then take over the job to this one. Okay, so this is the high availability. So it requires the hardware solution as well as the software solution. So Hadoop support HA. So using HA, the standby, the naming node will take over the job in case. What if both of them fail? Your system is down. So the Hadoop 3, the current version of the Hadoop, support more than 2, the naming node for the standby in case. But I never seen. So this one is the backup standby. So this is the standby, the naming node. It's a really backup of this one. Okay, so this is how to create. So don't do not forget, all of these are running on existing operating system and existing file system. So from the client, like the PC or one of the nodes, if you wanna use the HDFS, you need to upload. It looks like upload the file. When you upload the file and write the file, the name node will be used as a metadata, then copy it. So this is how to write the file. Can I update the block? No. Always HDFS is another characteristic is the write once. So write once and read many times. Okay, this is another characteristic of the Hadoop. Why? If we allow the update, random access, it will be overhead. It will be slower. So it is not easy to manage such a big data. So to manage, to maximize the performance of to handle the big data, take out a lot of the functionality and operation. So that because of that, the HDFS is not the fully implemented based on the POSIX, the operating system standard. It's the specialized for this. Then, write. When you write the data, so when you read the data, so there's a client also and request to read the data. At the time, I'd like to read the a.txt file, check the how many blocks. So there's a metadata, block 0, block 1, block 2. So the block 0 data node 1, 2, 3. So it will suggest the nearest node, which means the fastest node to, because it knows the heartbeat, monitoring probably, I do not remember, there's the checking the how, it's like using the ping, and then by the way, they are, for all the communication is based on RPC, remote procedure call. Why RPC? Do you remember? Another characteristic of the Hadoop is it's a Java implementation. All of these are implemented by the Java. Okay? So for the communication, it uses the RPC, the protocol. So using RPC, so then they communicate, and then they know which one is alive, which one is fast. So that's one the fastest one. Then the client directly contact to read the data. Okay, so this is how to read the data. Then this is the overall how the read and write the file is using the Hadoop. At that time, there are different applications. So we can use the Hadoop shell. So we will practice the Hadoop shell. And there's a Hadoop, the admin, DFS. I think that is a D. Ali? Is it DFS? Admin? Hadoop DFS admin?
Can you say that again?
The Hadoop DFS admin to use the Hadoop file system?
No, just HDFS, DFS.
DFS,
yes.
Right? So Hadoop DFS, so it's a DFS. It's a DFS, I think both of them are the shell interface, so you can read and write the file.
Yeah, you can use Hadoop FS or HDFS, DFS.
Okay.
There are two commands.
Yeah, two commands.
Yes.
Two share, so you can use you can practice in the exercise lab, most of that. Also, plus we can use the application program like the MapReduce. In the MapReduce, we can open the file or read the file and so on. Okay. So no matter what the interface you use, then for example, I'd like to use from now on, I'm going to explain the MapReduce architecture briefly. So MapReduce. The idea of the MapReduce is it's a divide and conquer. So first mapping means For example, the objective of the application is I'd like to read the a.text file. So a.text file is here. And the count, how many times of occurrence of each one. Like A is the 10 times. The is the 20 times. And the li is the 1 time, and so on in the file. Okay? This is our goal at the time. So it has the mapping and the reduce to the functionality. So eventually we will create the Java program for the mapper and the reducer. The mapper, during the mapper, so we are going to first ask the a.txt file to the naming node inside. Then the block 0 and block 1, block 3. So assign the data node 1, so block 0, and the data node 2 for the block 1, and data node 3 and the block 2. Then read the block by block. This is called the locality. So another characteristic of the map reducer, this is HDFS, the map reduce, the programming is we are going to use the locality. Locality means the job the application will be running on based on the block where the node where the block is stored. Okay. Sometimes to read the 0, it will be data node 2. If this node is faster, the node identified by the naming node, it will be assigned to this one. It may be different node, right? But it will be based on the node where the block is located. It's for the locality. Always it keeps the locality. So the block 0 is for the data node 1, data node 2 is for block 1, the block 2 is the data node 3. So 3 nodes will be running on simultaneously at this time. Then for each block, the count, how many times A1 and A1 and the 1 and the 1 and the li 1 and something like that, only one time. We are not going to combine in the local because it's overhead. Just count A1, the 1. Later we will add up all of this. Okay? So for each this one, and for each this one, for each this one, then that is the mapper, then send the result to the reducer. For example, this one is selected, the reducer, and here it will be add up. Then the output of the reducer will be stored as the HDFS file. Okay, finally. I'm not going to explain the details of the map reduce part, but to explain the daemon program process, I'm going to very high level to explain about how the map reduce is working. But the next class we will discuss more details about the map reduce. So this is a map reduce. At this time, there is a job tracker. Job tracker. I forgot not sure to make sure the name of that.